Hi everyone, my name is Maggie and I want to welcome you back for another physics tutorial video. So this question here came from another student. It's number 9 on their homework. Looking at it, in 1976, the Lockheed SR-71A Blackbird set a record speed for any airplane. That was 3,530 kilometers per hour. You observed this plane ascending at this speed for 20 seconds, and it flies at an angle of 15 degrees above the horizontal, and then 10 seconds later, and then for 10 seconds, I apologize. For 10 seconds, the angle of ascent is increased to 35 degrees. Calculate the plane's total gain in altitude, its total horizontal displacement, and its resultant displacement. So we're going to go ahead and we are going to start out with our XY coordinates. Okay, so we're going to start out here. And I'm going to go ahead and name them. So this is our Y positive, and this on this side is our X positive. So you want to make sure you always name your axes. So something that we need to remember is that in this problem, the speed or velocity, so V sub I, because it's initial, of this plane is 3,530 kilometers per hour. Now, something that's going to be more clear as the video goes on, we need to make sure that these are actually in the correct base units, because in order to use our formulas, we have to make sure that the velocity is actually in meters per second. So we're going to go ahead and we're going to convert that. So in 1 kilometer, we have a total of 1,000 meters, and in 1 hour we have a total of 3,600 seconds. And that's actually going to end up being 980.55 meters per second. So that plane is hauling. Okay? Now, a couple of our formulas that we are going to need to know. I'll put this in red. So the displacement for the x values, so the speed that's moving in the x direction is v sub I of x, because it's the initial, equals v sub I times the cosine of the angle, so degrees. And then going through the initial v, so the initial velocity in the y direction is v sub I times the sine of the degrees of the angle. Okay, and then whenever we get down to doing well, actually those two don't change, so we need to also figure out what y sub 1 is, and that's going to be v sub iy, which is why we need to figure that one out, times the first time, so the first duration, minus 1/2 of g times t squared. Okay, now G is our gravitational constant, so that does not change. You'll normally be given those in an exam, or you'll put that on your formula sheet. Make sure you have that value. It is very, very important, and I would suggest just memorizing it. So our x direction, v sub I, equals, or x sub I, is v sub I in the x times t sub 1. Okay? And that's also, you know what, I'll just leave that. It's fine. So, let's see. We do our initial ascent at that speed for 20 seconds. Okay? Our angle is plus 15 degrees. And then I'm going to go ahead and I'm going to make another XY coordinate plane so we don't get too confused, because it can get confusing doing a problem like this. So the next one in purple, for 10 seconds, the angle of ascent is increased to 35 degrees. From right here, we're going to go 35 degrees, and we're going to totally pretend, there we go, it's a little thicker. Now this right here, that angle, plus 35 degrees. Okay. So we're going to go ahead and we're going to start plugging in, because we need to figure out what this y distance is and what this x distance is for the initial t value. So we're going to go ahead and we're going to take our first couple of equations and we're going to go ahead and we're going to plug and chug. So in order to figure out how far we've made it in the x and y direction, we need to figure out what the speed is relative to those directions. So relative, the velocity initial relative to the x direction equals the v sub I times the cosine of the degree. So plugging in, that's v sub I, which is, and we're going to use our converted numbers, 980.55 meters per second. Make sure you remember your units, times the cosine of the angle, which is the 15 degrees, equals, and we're going to plug that into our calculator over here. I'm going to erase that from our last problem. So 980.55 times the cosine of 15. So in the in the initial x direction, we are moving at a pace of 947.13 meters per second. So 947.13 meters per second. So we're going pretty fast. Now we're going to go ahead and we are going to do the initial v. We're going to do the initial velocity in the with respect to the y direction. So v sub I times the sine of the degree. We're going to plug in the values. So it's 980.55 times the sine of 15. And that is going to end up equaling, let's see, 980.55 times the sine of 15. That's going to equal 253.79, because that runs up. So 253.79 meters per second. Okay? And let's see if we can make a box. Oh, no, I need an outline. We're going to make it tiny. So there we go. So that's for the first part of the first problem, okay? And now we're going to figure out the actual displacement. So in the initial y direction, so I1 equals v, so the velocity, the initial velocity in the y direction, times the time, minus 1/2 gravity times the time. So that's going to equal 253.79 meters per second, meters per second, times our time of 20 seconds, don't forget your units, minus 1/2 our constant of gravity, which is 9.81 meters per second, times 20 seconds. And that's going to equal, once we plug it into our calculator, 253.79 times 20 equals minus, or you know what, I'm just going to go ahead and do 1/2 times 9.81 parentheses, so times 20 squared. So I'm going to do the first value we got minus the second value that we got equals 3,113.8. So 3,113.8 meters. That's how far it's flown, okay? In 20 seconds. In the wide, that's how far up it's flown. Right? Yeah. So now we're going to figure out how far in the x direction that it's flown. So x sub 1 equals the velocity initial in the x direction times t1, because we don't have to worry about gravity or anything changing that. So that equals 947.13 meters per second times 20 seconds. Oops, I don't need that parentheses. So we're going to go ahead and we're going to plug that into our calculator. So 947.13 times 20 is 18,942.6. So 18,942.6 meters. So our plane has gotten pretty far. So now we're going to go ahead and, let's see, that right there was this part of the problem. We're going to do solid color. Come on. There we go. Now we're going to go ahead and we're going to do the second part of the problem, which is right here in purple. Okay? Because we got a lot of values we got to get. So I'm going to try and make this as even as possible. There we go. Close enough. So we are going to figure out just the distance displaced in the x direction and the distance displaced in the y direction. Okay? So we're going to go ahead and we are going to figure out our x and y displacement of our purple section, so our final x and y displacement. So we're going to do x sub f equals the velocity initial with respect to x times the second part of the flight. So that is 9 947.13 meters per second times, and then the time spent is 10.0 seconds. So we're going to go ahead and we're going to plug that in. So that's 947.13 times 10, and that's going to equal 9,471.3. So 9,471.3 meters. That's how far we've flown in the x direction. Now we're going to go ahead and calculate for the y direction. So the y sub f for the y final is the actual v initial times squared, times squared, minus 1/2 the gravitational constant times time 2 squared. So plugging in, that's going to end up equaling 980.55 meters per second, because we're getting that from our initial v value. Don't forget about that. Times 10 minus 1/2. Whoops, that's supposed to be a 1. 1/2 times 9.81 meters per second times 10 squared seconds. So we're going to take that over to our calculator, and it's 980.55 times 10 seconds equals, and then we're going to do 1/2 times 9.81 times 10 squared, and we're going to take that first value, we're going to copy it, and we're going to subtract the second value from it, and that's going to equal 9,315. So 9,315.0 meters traveled in our y direction. You know what, guys? I actually realized I just made a mistake. So this equation right here is incorrect. So we're going to go ahead and we're going to redo it. So the distance traveled for the final leg in the y direction is v sub I times the sine of the angle, so degrees, times t sub 2 minus, 1/2 gravitational constant times t squared. I apologize for doing it incorrectly the first time. So we're going to plug in our values. So that's 980.55 meters per second times the sine of 35 times the time, which is 10 seconds, minus 1/2 times 9.81 meters per second squared times, ours 10 seconds squared. And now we're going to go ahead and plug that value in, okay? So that was 980.55 times sine of 35 times 10. Whoopsie, I did that incorrectly. I'm just making all sorts of blunders today, guys. Outside of the bracket times 10. There we go. Good value. And then 1/2 times 9.81 times 10 squared. And we're going to do that first value minus that second value. And that equals 5,133.70. So 5,133.70 meters. And that's the distance we've traveled in the y direction. Now we're going to go ahead and we are going to figure out what our entire displacement is in the y direction. So let's see, I'll go ahead and redraw our coordinate values right here. That should be black. And our x value here. And now I'm going to go through and I'm going to just draw a triangle. Okay? I think that, yeah, that's about perfect. Oopsie. Well, that's not perfect now. Okay, that's close enough. Okay, so we are trying to figure out what this x value is and this y value is, so we can figure out what our total displacement of h is. Now, something fun that we can do, because this is almost a completely straight line, we've actually found this y direction in two parts, and we found the x direction in two parts. So we can actually go ahead and just add those together. So y total equals y sub 1 plus y sub final. And x equals x sub 1 plus x sub final. Okay? So we're going to go ahead and we're going to plug our values in. So for y sub 1, we ended up getting 3,113.8 meters plus our y final, which was 5,133.70 meters. Now we are going to go and we're going to plug that into our calculator. So I'm just going to go ahead and clear this so we don't have to look at anything. So we have 3,113.8 plus 5,133.7. And that's going to give us 8,247.5. So 8,000, I forgot the number. 8,247.5, I believe, meters. We're going to pretend that that is all in one line. Yeah, awesome. So we're going to go ahead and clear that again. So now we're going to do the x values. So that was 8. You know what? I don't think, oh, yep, I didn't write it in yet. So we're going to go ahead and plug the values in. So it was 18,942.6 meters plus 9,471.3 meters. Now we're going to go ahead and we are going to plug that value into our calculator. And it's going to be 942.6 plus x value is 9,471.3. 28,413.9. 28,413.9. I believe. I want to make sure I got that right. Whoopsie. Before I. Yeah, 13.9. And then I want to make sure I calculate the correct y value because I am actually recording this pretty late at night, so I'm pretty tired. I had a full day of classes today. Whoop, nope, not 9. That was 5,133.7. 82475, 824.7. Okay, awesome. So, if anyone remembers our h value or our h formula, so h equals the square root, of all the x's, the sum in the x direction squared, plus the sum in the y direction squared. So text it out as SQRT parentheses x squared plus y squared in parentheses equals SQRT. We'll plug in our values now. So that's 28413.9 squared meters plus 8247.5 squared meters. And then that's gonna equal, once we plug it into our calculator, I'm gonna try and minimize this as much as possible. So you know what, I'll just put it over here so I can see what I'm doing. There we go. Okay, so I'm gonna clear this. So it was the square root, so shift square root sign, 28413.9 squared plus 8247.5 squared, and hit enter. So that was 29,586.7. So it's 29,586.7 meters, and that's our H value. So that's the total distance that it has currently taken. Okay, so that is our resultant displacement. So our total gain in altitude is our Y value, our altitude right there. Our total horizontal displacement is our X value, and then our resultant displacement is our H value, because this right here, whoopsie, this right here is total displacement, this is displacement in the Y, and this is displacement in the X. So I hope that worked out for you guys and it was helpful. Let me know if you have any more questions, comments, or concerns. Leave them down in the comment section. I will try and go through and answer any questions you have. I might leave a link to a handwritten set of those questions. So just, have a wonderful night, and I hope you guys do well. Until next time, bye-bye.